Good morning. Thank you for joining us. Welcome to this month's Instant Insight webinar brought to you by Arrow SI's Learning Services. Today, Andrew Prokop will be speaking with you about WebRTC and what you should know from Arrow SI's perspective. Just a few notes as we go through the presentation. All lines are now on mute. If you have any questions, you can have the option to type a question in the chat box. With that said, Andrew, I will hand the line over to you.
Right. Well, good morning. Thank you again. Again, my name is Andrew Prokop, and I'm here to help you understand the fundamentals of what I think is one of the most exciting communication technologies of our time, WebRTC. I wear many different hats here at Arrow Systems Integration. Some of you may know me as the SIP guy, and it is true, I really do get excited about session border controllers. Others of you may know me for my weekly No Jitter articles or my less frequent but still plentiful articles for the Avaya blog. What you may not know is that for the past 20+ years of my career, I was a software developer, and I love exploring new technologies by rolling up my sleeves and exploring them from the inside out. That was definitely the case with WebRTC. In order for me to fully comprehend exactly what it is, how it works, and the value it brings, I actually wrote my own WebRTC application. Granted, it was fairly basic and not all that pretty to look at, but I was able to create point-to-point video calls and chat sessions from within a web browser. In the process, I learned the technology as I grasped why it's such a big deal. It's one thing to read about WebRTC. It's quite another to see it in action. So while I won't be taking you on the exact same journey I went on, I hope to use my experience to help you see what I saw and why I am so excited to talk to you about it today. And speaking of today, let's take a look at what I intend on covering over the next 45 minutes to an hour. So we're going to begin with really what is too many W's. What is WebRTC? And I'm hoping that you came to this webinar because you have some inkling as to what it is, and maybe some of you have more than an inkling and you want to hear a different insight. But I'm going to go in from the ground up and explain what it is and why it's important and all of that. I will then go off into uses, different applications, and I'll spend a little bit of time on a couple specific ones that I think are pretty exciting. Then we're going to get a little bit geeky and go under the covers, and I promise you it won't be too scary, but I will show you some of the aspects, the lower level technology, some of the terminology that I think is really important for you to understand. Important for you to understand as you are perhaps a business unit leader and you're going to roll out WebRTC, and you need to understand what your developers and what the technology people are talking about. As a technologist, I want you to understand some of the things that are happening under the covers that might be important to how you build a solution. But again, I'm not going to teach you how to write a WebRTC application, but just give you enough of a flavor so you understand some of the challenges. And as an IT director, if you are building an infrastructure for WebRTC, I want you to understand some of the things that come into play. We're then going to go into some of the tools and the APIs, the applications, programming interfaces. WebRTC, as you'll see, is a standard, but I'm going to show you how to at least talk about some of the things that are happening to make it easier to use, to tame the standard, and make it so that you can create your applications perhaps quicker than if you just coded to the bare metal. Some of the issues, like all new technologies, like any technology, there are issues, and especially one that is new as WebRTC. So there are things that could be considered problems. We'll see about that if they're necessarily a problem, but there are things that you need to be aware of. Then we'll talk about what's next. We'll talk about some of the things that are happening, some of the trends, what's coming at you in the near future. Because any technology, if it goes stagnant, it becomes almost worthless. So WebRTC is new, and it has a lot of promise, and there's a lot of growth. And then finally, questions. And I really hope that you ask questions. You will see a little box for your asking your questions over in your GoToMeeting little window. So ask your questions there. I will get to them at the end. One of the most common questions that we get all the time is, will we get the slides? And yes, you will get the slides, and there will be a recording made of this. So you don't have to ask that one. It will be coming. So let's move along. Let's get right into the meat of the thing. So let's start off. What is WebRTC? Well, it stands for Web Real-Time Communications. We all understand what the web is. We understand what a web browser is, and we understand what it means to go to a web server and download a web page. And the web page may have all sorts of pictures. It may, a lot of text, maybe some forms that you fill out, any number of different things. Well, the WebRTC aspect is we're going to add communications. We're going to add real-time communications. And what I mean by real-time is, like what I'm doing right now. I'm speaking to you in real time. You're hearing my voice as I speak. Of course, there's a little delay, but in a sense, you're getting it immediately. You're getting it as fast as I can get those atoms over to you. The same thing would be in the case of video. So if I start up a video connection, you clearly want to see me as I'm talking. You want to see my lips move as my words are coming out of my mouth. We want that synchronized as well. So there's that real-time communications aspect. So web, real-time communications, that's WebRTC. Now this is really important. It's plug-in free. Now, I am sure that a lot of you, like people today going on to GoToMeetings and things like that, and you want to go on to some sort of a real-time communication system over the web. You've done that already, but you've loaded something. You've loaded a plugin. You've loaded some piece of code from whatever vendor is supplying that technology down to your PC, down to your Macintosh, down to your Windows PC. You've done something. You've loaded something. WebRTC is plug-in free. There is nothing to download. If you were to go on to a WebRTC conference, it wouldn't be such, oh, now click this to download this thing, and then you go and install it, and you run it. No, WebRTC is actually built into the web technology, and I'm going to go into that into a little bit of detail in just a bit. But there's no plugin. You don't download it. It's also application free. What I mean by that is you don't necessarily have to download an application like Skype, or you don't have to have FaceTime. And these are all real-time communication systems, but you're doing it through an application. So again, you're going through the effort of acquiring the application, downloading it, installing it, running it, and all those sorts of things. That's not WebRTC. Again, plug-in free, application free. Now there will be points where there are things that are downloaded. Okay, there are things that are downloaded, and I will talk about that, and I'm going to talk about why that's different than what I'm talking about here. So just hold on for a bit. So what is it, though? It's really browser-to-browser media. So you have a web browser. You bring up Firefox. You bring up Chrome. You bring up Opera. And now, finally, you can bring up Microsoft's Edge. And you go to a web page, and maybe on that web page it says, hey, do you want to talk to me? Do you want to hear my voice? Do you want to send your voice? Do you want to start a video chat session? So you would click a button, and that it instantly happens. You're not downloading anything. You aren't loading anything. It's built into the web browser itself. And again, I will talk about what that means when I say it's built into the web browser itself. So web real-time communications, plug-in free, application free, browser-to-browser media, voice, video, data. So data could be a chat session within a video session. It's a standard. It's a standard from the W3C, the World Wide Web, those are the 3 W's consortium, and the IETF, the Internet Engineering Task Force. These are the people that give you Internet technologies. So the IETF, they're the people that give you the DNS technologies, the things that you use for finding addresses on the web. They're responsible for all those things. They're also responsible for things like SIP, and I'm going to talk a little bit about SIP as so you can understand where it all fits into all this. And then W3C, these are the people that do all the web protocols, the ones that you use on your web browser to get access to all this information wherever it might be across the world. So it's a standard from the people that deliver Internet standards, and that's a very important thing. This is not coming from a company. This is not Apple or Google, although they're part of these things, not so much Apple. We'll talk about Apple a little bit later, but the Ciscos of the world, they're not saying, hey, here is our technology, use our technology. It's a standard. This is a bunch of people getting together to deliver something that everybody can use, so it doesn't have to come from an individual company, an individual product. So let's think about some of the markets. So let's think about the idea of starting with healthcare. In fact, it's almost anything you really want to think about. Where would WebRTC become applicable? And if I'm a patient and I want to communicate with my hospital and I want to just go to a web page and I want to have a nurse hotline. Let's have a nurse hotline that allows me to speak or do video. I can say to the nurse, I've got a cut. Well, here it is. I will show you through a video connection. And I don't have to already have an arrangement made with the hospital where I get an application and all that. I just go to the web page and I click on a button and I start to communicate. Maybe I choose to do video, maybe I choose not to do video. But again, healthcare could be a big use of it. Higher education, I can see quite a bit of that as students come and go. Students bring their own devices into the campus environment. You want to enable those students to communicate with staff, with professors, with other students. And you don't have to want to worry about, well, how many different applications do I have to support? I just want to basically build up a web application and let them get access to it. Any different types of customer services, any customer service, I can see that. Conferencing. I believe that there's going to be a big use, and there already is. There already are people that are developing conferencing products using WebRTC. So you go to their WebRTC-enabled web page, and you can start conferencing, and you don't download that plugin. You don't have to load up that extra code. Social media, and social media has already started to use it, and I'm going to show you that in just a minute. Facebook is starting to adopt WebRTC. Again, for some of the reasons that you're going to hear just in a little bit why they're adopting it, but again, social media, big use. Any kind of a customer portal, and really it's sort of et cetera, et cetera, et cetera, et cetera. Where do you want to add this technology? As we go through the presentation, I'm going to show you different places and different things that people have done with WebRTC. So give me a few reasons. Well, my goodness, viruses, malware, industrial spying. You'd be surprised at how much industrial spying is occurring. But people are growing reluctant to run plugins and new software. They are. Companies are locking down systems. They are telling their employees, you can't do anything unless it's approved by my organization on the device that I'm giving you. Well, that makes their IT department always having to scramble when somebody says, oh, I need to run this, now I need to run this, now I need to run this. People don't want to do that anymore. They don't want to download things onto their devices because it opens up a security risk. And there are a lot of different reasons why. And again, it's viruses, malware, spying, ransomware that you may have heard about. Well, if we start to build this technology into the web browser itself and into the protocols that the web browser uses, then we don't have to worry about this download anymore. And we don't have to worry about, again, opening ourselves up and perhaps introducing security risks. Need for rapid development. We're a very fast-moving world. We need things quickly. With WebRTC and having the technology, again, built into the most common application that every one of us uses day after day after day, the web browser, it allows us to rapidly develop and deploy these applications. And again, they can be deployed on a wide scale. You develop the application, you put it up on the web server. When they go to the web page, boom, they have the application. They have the application because it's, in a sense, built into the web page itself. It's not an external thing. It's built into the web page itself. Embedded communications. We add communications to the tools and systems that require it. So I've been talking about web browsers. And I've been talking about web browsers because that's the model that people think of when they go to a website, as they go through a web browser. But web browsers really implement an underlying technology, which is, you've seen HTTP, / hypertext transfer protocol, and then underneath that is HTML. HTML, or the format of the information that comes down to you. And web browsers do that really well, and that's what they're designed to do. But that technology can be embedded anywhere. And so just because I'm talking about web browsers, I'm really talking about web technology. And so the ability to get access to those web servers, to grab that information, which happens to be this HTML file, to grab that and to display it, or us techies like to call render it take the content of that file and render it, make it visible or audible or whatever that means to display, in quotation marks, display that technology, display that information. That can be built into anything. So again, we have rapid development in all of the places that we need it to be developed rapidly. And then this thing called the Internet of Things, IoT. And I hope you are paying attention to IoT because it is something that's going to change your life, if not already. Some of you have Fitbits. You wear your Fitbits and you walk around and it gathers information about you, how many steps you've taken, how many calories you're burning and things like that. And it gives you access to that information through some other portal, like an iPhone or a PC. That's Internet of Things. We're basically attaching, we're turning everything into an Internet-enabled device. If you read the things I do at nojitter.com, my article this Monday is all about something that we did here at AeroSI, where we wanted to see what our customers, our employees thought of Internet of Things. And we had a contest, and we asked people to just submit ideas, and we got some very clever ideas of what people want to do now that everything has an IP address and everything can be communicated to. Well, those devices, well, why don't we add communications, and why don't we add this standardized way of communicating? So the Internet of Things is really going to change things quite a bit, and I'm going to talk a little bit about that when I get into some of the examples, like right now. So here are some of the real-world examples. Some of these things are relatively new. Some of these things have been around for a little while. When I say around for a little while, in the state of WebRTC, that means a year or more. This is not, certainly 20-year-old technology, but a year or more. But see, there's some of the things that are happening. Unify has a product called Circuit, which is a team collaboration application. It's really a web page. You go to the web page, and you can do all sorts of stuff in team building. You can have your buddy lists, and you can have videos and voice and different chats and different levels of things that you would do with team collaboration. It's built on WebRTC. MindMe, that's an application I want to spend a little bit of time on the next page because I want to dig into that one a little bit deeper. This is one that really excited me, called Live Ninja Katana. And what that is if you have a web page, you're a business and you have a web page and you want to WebRTC enable that web page, they have software that you can then, or basically an interface, you just basically drop it onto your web page, and then it gives, and then the back end, they have all the ability for contact center agents to handle these inquiries coming across WebRTC. Plus, they have some other things if the connections aren't what they should be, or we have we have some problems with the bandwidth and things. They can actually move over into the PSTN and turn these WebRTC calls into phone calls. So that's a kind of a hybrid approach, but a pretty cool product. Some of you have heard about Cisco Spark, Cisco's new cloud offering, WhatsApp, and I say somewhat because they've taken little bits of WebRTC, not all of it, but they've taken little bits. So it's a nice step forward. I expect that in time they may take all of WebRTC. Facebook Messenger, the mobile version is mostly WebRTC. They've applied most of the WebRTC technologies for Facebook Mobile. There's a place called OnSIP, Hosted Voice over IP. One that I ran into just recently, a video in their product called VideoWorks. Interactive Intelligence, I ran into that one just the other day. And they are using WebRTC to get access to their cloud-based contact center. And then Ring Central. Ring Central is it's a platform as a service, unified communications as a service, service. And they have WebRTC. They're building WebRTC into that as well. So you have the idea of traditional phone calls, and you have the idea of WebRTC. And it's just happening all over the place. And sometimes you know it. Sometimes you don't know it. Sometimes it's really obvious. Sometimes it's not. I mean, did you know that was inside of Facebook Messenger? Probably not. Some of the other things, you might not know that it's there, but that technology is really starting to become mainstream. And I promised that I would single one of them out. And this is a really interesting application, and it will give you a good example of some of the WebRTC technology. And it will also go back to my statement where I say you don't download anything mostly. MindMe is an application that was developed for a very serious topic for suicide prevention. So if you are somebody that is suffering from depression or some other issues, that you would have the MindMe application, let's say on your iPhone or your Android device. And throughout the day, the application will actually ask you, hey, how are you feeling? How are you doing right now? And you can say very good or okay, bad, very bad. If you start to get into those scary places, it will then perhaps, well, let me ask you a few more questions. Maybe do you need to see the video that we discussed the other day? And then at some point it might say, there's something more serious going on here. And it will create a WebRTC connection back to a provider of some sort, either an emergency responder or a therapist or a nurse hotline or something to guide you through what you need to do to basically stay healthy and sadly sometimes to stay alive. So MindMe, so it's a WebRTC application that, again, iPhone, Android. Do the users know that it's using WebRTC? No, they don't, but they know that it's actually reaching out and doing communication back to, again, somebody that can help him or her. And I wrote an article about it. There's a link down there on the bottom, no jitter, about the MindMe application, and as I say, WebRTC for the greater good. So here's another one. My friend Amir, he works for AudioCodes. When Amir sends me an email, at the very bottom of his email, this is a little signature, and one of the things is call my link extension using WebRTC. If I click on that, then this little thing pops up, and I have a conversation with Amir. So right from within an email, I have this technology embedded. So remember I kept saying it's not really just web browsers, but it's web technology. Well, it can be embedded inside of an email. So I just click, and I'm talking to Amir right from the email. So a couple of things. We're going to this is the getting down and dirty a little bit. So let's talk a little bit about the WebRTC Stack. And I promise not to get too geeky on you, but there's the idea of the API. That's the thing that the developers will write their code to. And then there's the aspect of identity. And I think of identity as protection. Who's making this WebRTC call? Is that really Andrew Prokop? Can I be sure that that's Andrew Prokop and it's not somebody pretending to be Andrew Prokop? SDP, that's the media portion. So that is, well, what can I do from the media standpoint? Am I trying to make a video call? SDP for Session Description Protocol. Am I trying to make an audio call? What am I trying to do? So I'm really exchanging my media capabilities. And this thing, ice, stun, and turn, I'm going to get into that in a little bit. That has to do with how do we get through firewalls and how do we get, really navigate networks. And then I talked about security as part of the identity, but we also want to have things like security in terms of protecting the data that's moved. So if I'm on the internet, I'm making these connections, and I'm sending my video and I'm sending my voice, I don't want anybody looking at me, and I don't want anybody, just anybody looking at me. I want the right people, and I don't want anybody, just anybody, listening in on my conversation. So security, I need to do things to protect that. And then this idea of codecs, and codecs are what's the media types that we're exchanging. And geeky people like me, we like to talk about G711 and Opus and H.264 and things like that. Those are the actual bit encryptions to take an analog world, analog, we see with our eyes and we create analog waveforms. We hear with our ears and we create analog waveforms. We have to somehow convert those into a digital format, and that's what a codec is all about. So let's look at kind of the big picture. I've been giving you some examples, and again, sort of a nerdy slide, but not too bad. If we look over on the left and the right, we have peers. So we have these two, in this case, they're PCs and they're running web browsers, and they need to talk to each other. We want to start a WebRTC connection between two web browsers. So we need to do some sort of signaling. So we send some signaling up to some signaling cloud, and I'll get into that in just a little bit, which really means, Andrew is on the left side and, Kelly's on the right side, and Andrew wants to talk to Kelly. He needs to somehow communicate to something that knows where Kelly is. So there's a signaling element in the middle, kind of like a phone book almost. You open up the phone book and you find the phone number and blah, blah, blah. That's the signaling element, okay? So, hey, Andrew wants to talk to Kelly. And then the signaling element would come down to Kelly and says, hey, Kelly, Andrew wants to talk to you. And then you could say, well, I'm cool with that. Let's talk. And it would send information back and forth. At some point, you decide everything's good. We're going to talk. Well, we need to now send media. And we want to send the media directly between the web browsers, between the WebRTC applications. So we drop out of that whole signaling thing. We're no longer talking to this middle person, mostly, kind of, but I'm not talking to the signaling element anymore, and I want to send the media between these two elements. Now, as if you're inside of a same company, everything's probably fine because there are no firewalls between the two of you. You can send the media directly, but what if you wanted to send that media from home to your a customer of, let's say, a Target, and you want to communicate with Target? Well, you're at home, you're on, whether let's say you use Charter internet services, and well, you're on their network, and they're giving you a private IP address, and you need to talk to Target, and Target's behind a firewall. Well, that's where some other technology will come into play, which I'll address a little bit, to get you through those points that don't want to let you get through. So how do we do that? And that's your NATing, network address translation, and we'll talk about that in a little bit. But the whole point is the media then goes from browser to browser. Now, whether there's something in the middle to kind of fix up the addresses, regardless of that, the media goes from browser to browser. So I told you there's an API. And I kept talking about web technologies, and I kept talking about HTML. Well, HTML, hypertext markup language, that's the thing that gets sent down to a web browser. Well, HTML5, version 5, actually extends that. So it has, not only does it have the things to say, draw this pretty picture, collect this data, put this line on this page, whatever, it has the ability to start setting up call information or communication information. So we see this RTC, RTP sender and real-time, communication senders and receivers, and ignore all that. Just know that it's there, and it could be within standalone or embedded web browsers. And remember, I could say I'm talking about web browsers, but it can be embedded in lots of other things. And one of the big uses of WebRTC is not necessarily actually going to be the web browser. It's going to be apps that you download to your smartphone that have the web browser technology built into them, has that technology built into them. So even though they don't look like a web browser, they're actually doing all that HTML stuff, and they're sending things back and forth. So they're taking advantage of the web browser technology, and they're presenting it into an app. And that's what I mean by sometimes you do download things, but that's a little bit of a different experience. Let's say that I fly Delta Airlines a lot. Delta could add WebRTC into the Delta app that I've already downloaded that allows me to know when my planes are going to be late and how many frequent flyer miles I have and all that sort of things. I could put that technology into the app and say, hey, I have a problem. My flight was canceled. I'm in Atlanta. I'm trying to find another one. I can't find a good flight. Call an agent, and I'll just press something right inside of my screen, and that will create a WebRTC call back to the agent, and then I'll still be on the screen where I'm looking at what flights I'm trying to get. The agent can get that information because I can share that through a data channel, and we can have a much better communication than if I just said, oh, let me get out of this app, and now let me find the phone number, and let me call it. No, I've lost the context of what I'm supposed to be doing. The agent does not know where I am on that page, because we're not on the app anymore. So that sort of thing can happen. And then a lot of the standard tools. So this is web technology. So the standard tools, the HTML for displaying those objects. When I want to put that video screen on my, my browser, I want to put the chat window on my browser. I want to put the words that say chat with me, call me, click to call, whatever. That's all standard HTML display technology, web technology. And then this thing called JavaScript. And this is the most common way to see to write your WebRTC application, those WebRTC objects, those things, those funny things I have up there, the CR, RTP sender things, that's using JavaScript to say, I'm going to get a little lower level, and I'm going to talk to elements within the web browser, and they're going to support these things, and they're going to do all the communication stuff. So, display information and then the control information. And this is kind of ugly, I apologize, but this is a little snippet from an application that I wrote, and you can see at the top there's, I'm putting a video box up there, and that's where I'm going to display my video screen and all that. I've got my sender, I've got my receiver. I'm not showing you all the stuff. I kind of trimmed this down significantly. But I'm also loading up these JavaScript things, and I'm saying, well, here's some code that I want you to run. And if I was to show you the whole page, you would see that when the page gets loaded, it runs certain code and blah, blah, blah. So again, it's part of the web page. So I go to the web server, it downloads this stuff, it gets executed, the web browser says, I'm good with this because I know and I understand WebRTC, and then no plugins, no downloads, nothing other than the normal transfer of information from a web server. So some of the signaling. I talked about signaling. Well, what is WebRTC signaling? Well, the thing is, It's whatever you want it to be. When the WebRTC people developed WebRTC, they did not want to lock anybody into anything. They didn't want to say, hey, you know, we're like old school telephone people, and we're going to pick a way that you're going to communicate. They actually left it open to do anything that you want to do. Now, that's a little scary in some ways, because what do you mean, anything I want to do? So I can do anything? And the answer is yes. Any way that you want to tell me. Let's go back to my example of Andrew and Kelly. That how does Andrew tell Kelly that he wants to talk with her? The answer from the WebRTC people is any which way you want. And there's certain technologies that people commonly use. There's WebSocket, and there's comment and jingle, and you can use SIP, and there's some people using a SIP, and I'll talk about that. You can use smoke signals. It doesn't really matter because WebRTC doesn't care, and it's a very important thing. And the important thing to think of why that's so important is because if I develop a WebRTC application and I don't talk to you who are developing a WebRTC application, the chances that we can interconnect are nil. Because what's the chance that you're going to come, well, I shouldn't say nil, but pretty close to nil. What are the chances you're going to think of the same thing that I thought of? Probably not. So you think, well, geez, doesn't this make it worthless? Well, the answer is no. The answer is, well, if I'm creating that application that runs inside of my, let's go back to Delta, my Delta app, and I want to create a call that communicates with my Delta agent. That application only communicates with the Delta agent. So when I create the solution, I create it end-to-end, both my end, which is, you know, my Delta app, and the Delta end, which is the agent. You know, I can create whatever kind of signaling I want to do. This is not a just generic telephone call. This is communicating back to Delta. Let's say that I have a Kindle, and I want to have some Kindle app that communicates back with the Kindle store because I got this book and it has naughty words in it, and you didn't tell me it would have naughty words in it, and I'm upset. Well, this is the Kindle app communicating back with a Kindle agent. I'm not making a regular phone call. So the idea of allowing the signaling to be whatever you want actually allows a lot of flexibility. I think I put it in there, flexibility by design, because I can do anything I want. Now, anything is a scary concept because, again, what if you don't have a, you know, your signaling is completely different than mine. There are ways that is being addressed. There's a technology called Matrix. I'm not going to get into Matrix, but there are people that are addressing that, which act as gateway services. So if you write an application, you register against Matrix, and it says, oh, I know what this guy is, and I know what that guy is, we'll make them work together. It's way more complicated than I want to talk about in this webinar, but that is being addressed. So media, well, I said it was defined earlier by SDP, Session Description Protocol, just like SIP, but it's not SIP, but it uses some of the same technologies. And then those codecs that I talked about. G711, that's old school telephony. G711 was invented in 1972, and for those of you at home keeping score, that was the year that I entered high school. And I'm an old guy, so that's a very old codec. And some people are using some of the newer ones, ILBC and ISAC and all that. But really, G711 is a requirement, and Opus is a requirement. So if you create a WebRTC solution, you have to do both of them. Opus I'm going to talk about in just a second. Opus is not my high school days. Opus is pretty darn new, and it's a much more powerful codec. And that's audio. And then video, we've got H.264, which some of you may know as MPEG-4. And then we have VP8, which is a codec that I don't want to say was developed by Google, but Google had a big part in it, and it's moving towards something called VP9. These are a high-definition variable bandwidth codecs for video. And then there's a separate point-to-point data channel. When I wrote my little WebRTC application, I had a video connection, and I used H.264 to create my video connection back and forth. And then I had a little chat window. So, you know, if my little application, if Kelly and I were talking, I could be sending across my video stream to her, and she could see me smiling, and then she could send me a chat on the side that says, your color is askew, you know, and then and so if we were in a conference, nobody would know, but, you know, I would know that Kelly said my color is askew, and I would fix my color. So anyway, it's a separate data channel, but that data channel could be anything. It could be screen share. It could be data share. Go back to that Delta app. It could be all the information about this person's flight, what they're looking at, and blah, blah, blah. Okay, Opus, I promised a little bit about Opus. I don't want to spend too much time, But it is a really cool codec. So again, remember 1972 for G711. We always talk about G711 toll quality, like it's the king of the codecs. Well, 1972, what has changed since 1972? I'll tell you, a whole bunch of things have changed since 1972. How many things do you use today on a regular basis in technology that were developed in 1972? Not a whole lot. Well, I am right now, because I'm actually on a SIP phone communicating up to the go-to services on a SIP phone, and I'm running, oh my goodness, I might be running G729, which is almost as old, but let's say I'm running G711. I'm running that's old stuff. Opus is new. Opus does wideband. It has variable bit rates from very low numbers to much higher numbers. The quality of an Opus call is clean. It's a beautiful sounding call. One of the really cool things about Opus is it can be both for speech and music, and it can be mono and stereo, which means the same kind of technology that I would use to perhaps stream video across, or music. I shouldn't say video. Did not mean to say video. Music. I could use Opus to do that, and so I get that kind of quality. I don't want to say CD quality, but we're getting really high quality audio connections. And one of the really cool things about Opus is it's been designed to deal with bad networks. And I saw a test that somebody ran, actually with my friends over at AudioCodes. They ran this test, and they did a number of different codecs, like G729, G711, Opus, and then they allowed you to increase noise on the network, packet loss on the network, latency and jitter for you, network head guys, and you would see how those codecs would be affected by those things. And the codecs like G711 and G729, the sound quality got worse and worse and worse because they could not compensate for these poor networks. Opus was, my goodness, on a good network, it sounded really good. On a bad network, it sounded pretty good. So this new technology handles difficult situations a whole lot better than the old technology. It's newer, it's shinier, but it truly is better. So Opus, two codecs, audio codecs that are, in a sense, in the requirement of a WebRTC. If you create a WebRTC solution, you're supposed to support both the codecs. But at a minimum, you're supposed to support G711. And I'll get into that in just a little bit as to how we could use that. All right, remember I talked about firewalls and private IP addresses. Well, I won't spend too much time on this, but just so you know, there's some technologies that are built into WebRTC. One's called stun. And what that means is, again, let's say that I'm sitting here in AeroSI, and I'm sitting in my PC, and I want to create a WebRTC connection with one of my friends over at JP Morgan. Okay? I have my own private network. I have my own private IP addresses. I have firewalls. I don't want I can't afford to buy public IP addresses. I really cannot afford for all the employees here. It's flat out impossible if you could. And same thing with JP Morgan. So we do these things called private IP addresses. Private IP addresses are duplicated across the world. Everybody is using the same private IP addresses, but we mask them. We hide them behind this firewall so that when we get to the outside world, we only show a very few number of public IP addresses which we purchased. And inside, we can use as many of the private IP addresses we want. We don't have to pay anybody for them. But if I want you to talk to me directly from my browser to your browser, I can't just give you that IP address because it's worthless. You cannot send to it. And so what stun allows you to do is to say, hey, it allows you to get through these firewalls and network, and handle this network address translation. Allows you to say, this is my private IP address. Will you tell the other person a public IP address that other person can send to? And then they can send to the public IP address. Turn is a little bit different. And say stun just says, what are you? And here you are, and you send direct media. Turn is a little bit different. Turn says, I want to stay in the loop, and I want to actually relay the media from place to place. There are lots of free stun servers in the world. Lots of people will do this for you. Turn servers are more complicated, and because they require bandwidth, they're using media all the time. But there are cases, and I'm not going to get into all the detail why you would want one over the other, but a stun server does the same kind of things, and they often work hand in hand to get the media from one place to the other. And that's all I'm going to get on that geeky stuff there. But let's talk a little bit about security. Signaling, that signaling thing I told you about, well, you don't want that information publicly available. So we can do things like encryption. There's this thing called DTLS, Datagram Transport Layer Security. The only thing that you need to think about is when you go to a web page, you go to a bank, and you want to start sharing, private information about yourself, your account number and your account balances and all that. You know how your little web browser gets the little lock up there? Sometimes they change colors up there, and you go to this thing called HTTPS, Hypertext Transfer Protocol Secure. So what happens is all of your data is encrypted. So it goes through 128-bit encryption. So if anybody snips the wire, picks up your data, they can't do anything with it because they can't encrypt it. We all know all the stuff about the recent iPhone stuff, the San Bernardino, and they wanted to crack into the iPhone and all that. Well, it's not exactly the same technology, but it's the idea of you're securing, you're encrypting the data. Well, WebRTC builds in this idea of securing the data. So we're securing the signaling data, I should say, the signaling data that's going back and forth. So again, think HTTPS. And then media. I don't want my media being sent. So I talked about codecs like G711, and I talked about Opus. Well, we can take that data and we can encrypt that too in a very similar manner, so that if anybody listens in to my phone call, listening in meaning gets access to my data, you can't do anything with it. You can't encrypt. You can't play it because it's encrypted. And then this is a very busy slide, but the whole point of this is identity, is the idea that I can go out and I can prove that I am who I say I am. So if, again, Andrew calls Kelly, and Kelly wants to make sure that's really Andrew. In the phone company, we kind of get sort of that with caller, calling line identification. I can see that it's a telemarketer. It's a phone number I don't recognize. Same sort of thing here, similar sort of thing, so that when that little pop-up screen comes on Kelly's desk that says, Andrew wants to talk to you, she knows that it's Andrew. So all this gobbledygook is that it's actually securing the identity. And the best of the browsers will actually put up a little thing at the end once this little handshake occurs that says secure to aprocop@arrowsi.com. So I've secured that connection. So what are some of the challenges? Well, WebRTC is still in flux. It's new. Any new technology is still mobile, moving around technology. Well, WebRTC is like that. It's still in flux. There are things that need to occur, and I'll talk about some of those things that need to occur in just a moment. So these are some of the challenges. No defined signaling protocol. I gave that as an asset before. Well, it is an asset to some people. It's a negative to other people, and it's quite a contentious issue in there. There are some people that are using just SIP, probably a minuscule number though, because they feel that's a standard. More people are using homegrown things, and I'll talk a little bit about that, just a little bit more about that. So it's a challenge as well as an asset. Sometimes life is like that. Not all parties are on board. Apple and Microsoft are still not fully on board, although Microsoft is really getting more and more on board. They're proposing a competing standard, which is ORTC, Object Real-Time Communication. And ORTC, well, I talk about that just in a moment, but very briefly. But Apple Safari, if I'm on my, I have an iMac at home, I cannot do WebRTC connection. So this little thing up here where it says switch browsers to make a call. There may be some sites that just say, hey, I can do this on Chrome, I can do this on Firefox, I can do it on Opera, I can do it on Edge, but I can't do it on Safari. So you need to switch web browsers. I have to apologize. I know that there's some stuff happening in the Apple world. I'm not completely up to date on it. Things are happening over there with their WebKit. So maybe this will not be an issue in the near future, but it's an issue now. So let's come back here and let's say Taming the Beast. So I told you earlier about HTML5 and all those complicated things and all that. Well, there are a lot of people that are saying, you know what, WebRTC is way too complicated. Let us build solutions, or let us build interfaces, software development kits, that's what SDK stands for, that allow you to build your solution in a much easier way. We'll handle all the heavy lifting, the hard stuff. We'll do all that stuff that has to, pay attention to which web browser you're on, because unfortunately, you need to pay, am I on a Even though they're both WebRTC enabled, Firefox and Chrome support WebRTC slightly differently, sorry. So you have to code for that. If you remember slides ago when I had that my little WebRTC lib, my library, WebRTC adapter, it handled the differences between the different browsers. But there are a bunch of kits people that are out there giving you software that say, hey, write to my code. It's WebRTC underneath, but I'm going to give you something easier to use. And the last time I looked, there were over 99 of these people doing it. Some of them are focused on mobile devices. Some of them are focused on messaging. A lot of open source projects out there. So if you want to go to GitHub, if you're a developer type, you can get a lot of work that other people have done. And some of the more common ones, CafeX, very common. Big business, I shouldn't say big business, but they do a lot of work in a lot of areas. But one of the things is they provide you some very, very clever WebRTC interfaces and SDK. And then Candy, go back 10 slides in that Candy app, or I'm sorry, the MindMe app, the one for the suicide prevention that was actually built on Candy technology. So the developers didn't code to the lower level, they coded to that higher level. Now, as much as they make life easier, they also kind of lock you down. So once you start to code to Candy or CafeX or any of the other ones, and you get away from the bare metal, you are beholden to that API, and your application may not be as portable as you'd like it to be. I don't want to say that's a real true statement, but it is. Anytime you're putting something in the middle, you are now beholden to the middle. But the being beholden to the middle might be worth it because you saved yourself a lot of time and effort and development. So I want to walk through this one a little bit. This is one that comes from, it's very clever. This is from the Avaya world, and they're saying, well, I've got all these WebRTC customers, but I still have a back-end system that's built on traditional telephony. How do I get those people to talk to my call center agent? So if I have a customer goes and downloads the WebRTC application. Well, what happens is when they want to make a WebRTC call, we actually go through into my Avaya system through a thing called a reverse proxy. And then I communicate with this thing called the WebRTC Snap-in, which runs in the Breeze server, which is Avaya's technology for allowing you to build applications and put them onto an Avaya system. What says, well, I want to make a call. What happens is through a bunch of stuff is we say, well, we understand SIP. This other thing out here, we don't know what it is, but it's an HTML protocol. We will actually convert it to SIP. We'll send a SIP call down to the agent, and then when we send the media around, this is all the media going back and forth, and we send the media through an Avaya session border controller, and then we have this thing called the Avaya media server. But the whole point of all this is I'm sitting at a web page that says click to call, and my contact center agents are sitting on traditional Avaya phones. They don't have to be SIP phones, or they could be SIP phones, or I show SIP, but they don't have to be. But eventually, I have to get that call to them. So the WebRTC Snap-in acts as a gateway, so between a traditional telephony system and a brand spanking new WebRTC solution. Okay, I left off one little click. You can also have a WebRTC agent in there as well. I keep mentioning my friends at AudioCodes, and just because they do some clever things, and they built into their session border controllers WebRTC gateway functionality. So they can actually, using SIP over WebSockets, this thing called JSSIP, they can actually allow you to create a WebRTC call that goes to their SBC and then in turn goes inside of the into the traditional telephony system. So the one I showed you before was Avaya. This one's a little more generic to bring the call into a traditional telephony system. Okay. So we're getting close to the end, and I promised you a few things. What's next? So, well, the specification will solidify. Okay, so I should say, and it's actually solidified quite a bit in the last little while. So it is solidifying. So there's not as much of the loosey-goosey stuff. Multi-party support. So even though some people are doing it, some of it is out of the spec. So we get that into the specification as a whole. This whole widespread IoT adoption, the Internet of Things adoption, building a WebRTC applicable to that. Middleware. How do we get things in the middle of WebRTC? Because I have a whole back-end system of all these other things, voicemail systems and recording and all that sort of stuff. How do I allow WebRTC to participate in all of that other stuff? And then things like better statistics and reporting. If you're like me, you've been in the contact center space for many years. We know that reporting is very important. So how do we get that sort of stuff built into WebRTC? And then the ORTC, the Object Real-Time Communications, and WebRTC, they're merging. And I'm not as abreast of that as perhaps I should be, but I know that those sorts of things are merging together. And so that we'll have, in a sense, almost one and the same. And then Apple will finally really make up its mind as to where it's going and what it's going to deliver in terms of WebRTC. They don't want to be the last holdout. So how are they going to fit into all of that? Okay, so thank you. This is great. So we have reached the point where I am happy to answer any questions. And Kelly, that is going to be, I believe, what you're going to help me with.
Yeah, hi. Thanks, Andrew. So we do have one question. The first one here is for a telephony ACD environment, I can see the use for agent contact directly from the company website. Can WebRTC be used to connect the company ACD platform?
Oh, absolutely. And if we go back a couple of slides, again, if you're an Avaya user, I would highly recommend the WebRTC Snap-in, the Breeze Snap-in, so that allow you to connect your WebRTC with your standard contact center agent. So that's there. If you're not an Avaya person, then I would look at things like look at the AudioCodes solution. I would also look at maybe the Live Ninja solution to see how that would work in, because I know that they have a PSTN dial-around feature for that, which so the calls could look like they're coming in across the PSTN. So those are solutions that I would turn to. Again, via WebRTC Snap-in 100%, and then there are other ones if you're not. But again, that's a great question, because again, not everybody is WebRTC enabled. So what do you do with those old technology, with that legacy technology, when you want to interface with the new world? So there are solutions, there are ways to do that. So Kelly?
Yeah, we have another question. Do you have any full working examples for the developers on the line?
Full working examples for the developers? Well, I do, but you're not going to see them today. I will throw a plug-in for myself. I maintain a blog called SIP Adventures. My blog, SIP Adventures, actually had a 4-part series on writing a WebRTC application. I think it's called Writing Your First WebRTC Applications, Parts 1, Parts 2, Parts 3, Parts 4, where I actually go into the technology far deeper than you're going to hear in this webinar. And it ends up close to a working example. I don't give you all the source code, but I give you quite a bit of it. And I would also recommend, if you're a developer, go to GitHub. There are lots of people that have developed things like that. And there are some pretty good books out there as well, WebRTC books that come with CDs. Remember CDs, those old-fashioned things? Or actually, you can download it too. And they come with full flat, all the source code you need to use, and they come with their own signaling servers that you can build. When I built my application, I built my own signaling server. So I'm hoping that's answering the question. You're not going to get it today, but there are plenty of examples. Go to my blog, and you will find, again, at least a 4-part series walking you through.
Great.
Okay, Kelly?
Yeah, I think this might be along the same lines, but someone had asked how I can learn about WebRTC and the prerequisites.
Well, again, there's great books. My blog talks about it quite a bit. I have a whole articles on stun and turn. I talk about signaling. I talk about building a WebRTC application. So you just Google SIP Adventures. There are lots of things out there, tons and tons of stuff. Unfortunately, there's probably more than you can find easily, but I think even if you Google writing your first WebRTC application and put my name, Prokop, it'll probably come up with a bunch of links that'll get you to the right place. And then there are good books out there. Just go to the, wherever you like to buy your books and search for WebRTC, and I'm sure you're going to find some good ones. Okay?
Okay, great. Thank you. We also have another question. What's programming languages needed for WebRTC as I'm working with telephony from hardware side?
Whatever you can do, well, it depends. If you're talking about the server, it could be anything you want it to be. So it can be any language that you want it to be. If you're talking about the client side, it's generally JavaScript. So you're writing in JavaScript, which is not really a language per se, but it's a scripting language. It's not a programming language. So on the client side, I did all of my work in HTML and JavaScript. And on the server side, and this will sound kind of weird and scary, but my server was written in a language called Erlang, which is a very odd language. But I was able to steal some nice code from GitHub that gave me a leg up to do the work in Erlang. So, but the back-end services could be any language you want. But again, HTML and JavaScript for the what's the word I want for the client side. Okay, Kelly.
Great. Someone had asked, is Node JavaScript applicable here?
I'm sorry, say that again?
Is Node JavaScript applicable?
Yes, it could be. Yes, it could be.
Okay.
Yep. Any script, truly any scripting language that you can run within your web browser will do it just fine. So it doesn't have to be JavaScript. I just happen to tend towards JavaScript because it's the thing I know. So yes.
Do you know if Twilio uses WebRTC to your knowledge?
My understanding is that Twilio does have a WebRTC interface, yes. And Twilio allows you to build WebRTC, and they have some APIs and some things. Can't tell you all the details, but I know, I'm pretty darn sure that it's there. I was actually just on the phone yesterday with another similar sort of platform as a service provider, Ring Central, and I know they have it. I'm pretty sure Twilio has it as well. How does it all work? I don't know at this point in time. That could be my homework to investigate their APIs and how that's set up. But I'm pretty sure that it's there. I don't know why it wouldn't be. They're a very aggressive company in all the communication space. So I'd be really surprised if they don't have things going on in terms of WebRTC. Okay.
Sure. And we have one last question. Do you anticipate a future where SIP trunking is used on the back end, replaced by WebRTC clients on the end user side?
Did you say SIP trunking or SAP?
Nope, no, sorry. Where is SIP trunking?
Okay. Do I see? Oh, well, I could see that. It doesn't have to be, and the WebRTC purists would be jumping all over for me because they don't want anything to do with SIP. I apologize to you purists because I love you guys, but there's a real fight between we don't want to use SIP. They think it's too heavy, too bulky, and too big, and I don't disagree with that. I could see it on the back end, absolutely. Really, we're going to have to move the media across somewhere. How do we long haul it in various places? Is it necessary? Absolutely not. You could do it with one lick of SIP in any of this. You could do it all. They do have the SDP that they're using, which isn't SIP, but SIP uses SDP. And I think that there is a move front to replace that with a JSON, JavaScript object notation representation. But again, I'm not part of the specification crew. I'm not sure if that's near-term, long-term, or an option. So I hope I answered the question, but that's, as far as I know, that's how I would answer that.
Yep, we have a thank you, so I think we're all set there.
Okay.
Okay, so I think those are all of the questions and time that we have for today. But thank you, Andrew, and thank you, everyone, for attending our event. At the conclusion, we ask that you hang online and complete a brief survey. We value your time and your feedback. We will be sending out a copy of the slides and the recording from today's presentation. And please join us this summer we're launching our new data center series. The series begins June 23rd and will run through August. More details to come, but Dave Lover and Chad Frazier will be our speakers with a few surprise guest speakers attending. So that will conclude our webinar for today, and we thank you all for joining and have a great day.
Thank you, Kelly. Thanks, everyone.